Thanks, and hello everyone. I'm talking about Tika and how to kind of use it to fill in your full text search index with content from all kinds of digital documents that you may have. I work for Adobe, where we deal with a lot of different types of digital media, digital documents and stuff like that. And nowadays, like, you just have too many of them, and you need some way to keep track of all the content you have and search for it, classify it, categorize it, and somehow deal with that. And as you know, Lucene and all the technology built on top of Lucene is pretty good in all that kind of stuff. But the problem that we encountered some years ago already was kind of how to get all that information into Lucene in the first place. How to kind of crack open all these digital documents that we have, information in all kinds of file formats, and how to make that searchable, categorizable, and so on. And that's why we came up with Tika together with other people at Apache. So to give you a quick overview of what I'm going to cover today. First, I'll just briefly introduce what the Tika project is about, a few words about the project history and stuff like that. And then I'll give a kind of overview of how Tika can be used to extract content from documents. And then at the second half, we'll look at Solr and plain Lucene, see how you can integrate Tika and use the existing integration points that are already there. And then time permitting, I'm going to cover a couple of words of how to do some more advanced stuff, like forced parsing and then link extraction when you're dealing with kind of a pretty in-depth integration with Lucene and other tools. So to start, let's cover what Tika really is about. So when you go to the Tika website at tika.apache.org, you'll see this summary statement about what Tika really is, what's the scope of Tika. And it kind of summarizes pretty well like the key parts. So I'm just going to go through like word by word pretty much this thing. It's a toolkit, so it's kind of a library. It can do a little bit more than a typical library does, but it's not really a framework, so we're using the term toolkit for it. It detects, so it can detect what kind of files or documents you're dealing with. It extracts, so it can get information out of those documents. The information that it gets out of it is metadata. On the other hand, like who wrote this document, when it was written, what's the title of the document, and stuff like that. If it's an image, what size of it is, and how many bits are there, and so on. And then we get text content. So what's actually inside the document. If it's a Word document, then the plain text inside it. If it's some other kind of document, like whatever text we can get out of it. For example, if it's an MP3, there might be lyrics embedded in the document, then we get those out of them. You could even have a Tika parser that takes an image and applies OCR on it and gets whatever text stored in that image. And the text content is also structured, so not just a plain stream of characters, but we also provide access to the semantic structure of the text. So you'll be able to know like what are the sections in a document, what are the headings and so on, where there are links and stuff like that. So it's not just like a converter from a document to a stream of text, but a little bit more than that. Then it deals with various kinds of documents. So ideally, any kind of document that you have, you could feed it to Tika and it could do something with it. And that something is then depending on what kind of support there already is and what kind of libraries you have and so on. And the last bit it comes to that is we aren't trying to reinvent support for all document formats in Tika itself, but instead we provide glue to existing parser libraries like PDFbox or Apache POI or whatever libraries there are out there that already support these kinds of document formats, so that you could use Tika to get a uniform API and uniform access point to all these various libraries that are out there, and still get like the functionality and performance that's built into those very tightly scoped format-specific libraries. There are a few cases where we kind of had to bend the rules a little bit if there aren't very good libraries out there, or the libraries aren't licensed very friendlily. Then we've had to implement something in Tika as well. For example, our support for the RTF, rich text format, is we basically had to write our own because the existing stuff that was available in the JDK and some of the existing libraries was just not good enough. It was buggy and didn't support the features that we needed. But in general, we're trying to use existing stuff as much as possible. So here's the problem domain for Tika. All kinds of documents that you have, there are thousands of document formats out there. Hundreds of them are being used daily all around the world. And more of them are coming along every day, basically. So you'd kind of assume that with the internet and with the interoperability and stuff like that, we'd get a kind of a convergence to specific, just a few document formats. And that's true to the degree that, okay, HTML is pretty much the de facto for publishing stuff online. You have stuff like just a couple of presentation formats. You have PowerPoint, you have Keynote, and then you have HTML presentations, and that's about it. But then, like, already when you start looking at image formats, oh yeah, you have a couple that are really popular, but then all the image editors tend to have their own formats, and they have extra features and so on. And then every decade there comes a new image format, and someone invents something new, and then the stuff changes all the time. So it's a pretty complex domain, and basically no single project could cover it all. And that's why we kind of came up with the idea that, okay, we'll use existing libraries and then just provide the glue. So you don't really have to worry about all these different formats. You just use a single API and you get everything. So how this works in practice, basically you pass in whatever kind of a document to Tika, and then you get standardized text content and metadata out of it. So where we are now and how we came here, a few words about the history. It's been around for quite a while now, about 5 years. We started the project in 2007 based on a couple of kind of related efforts within Apache and outside of it. So we kind of decided that something like this would be useful. We're all doing the same thing over and over again. So let's combine our efforts and start the new project in the Apache incubator. And that we did, and it's kind of started gathering steam along the way. It wasn't too big at that time, just a couple of guys working on the code base. So we kind of felt that it's probably not big enough for a standalone top-level project. So we ended up graduating into Lucene, into a Lucene sub-project instead. And that worked pretty well until Tika kind of grew up enough that it made more sense for it to kind of become its own standalone project. Basically because so much stuff was going on there, and people on the Lucene PMC didn't really have that much to do with that code base. So it's better to have like the people who are actually working on the code make the decisions of what Tika is and when we can release and stuff like that. So And then last year, actually, we finally reached 1.0 status. It's basically a kind of, at that point, we figured out that, okay, now our APIs are stable enough and useful enough that we don't want to keep the reservation that, okay, if it turns out that this doesn't work, then we'll scrap it and do something different. So basically, at that point, we adopted a more conservative backwards compatibility promise, so that basically anything that is there will be there in a backwards compatible manner all the way until Tika 2.0. That isn't being planned today, so it might come someday, but that's probably a few years down the line and so on. And we also wrote a book about Tika. It was published last year. Me and another Tika committer did that. And basically that's where we are today. We published Tika 1.2 earlier this year. 1.3 is probably coming up in a few months, I'd assume. And today, Tika knows a whole lot about the media types and document formats that there are out there. We support basically all the major Office formats, all the major formats you notice when you kind of look around your file system or look around the web. And well, what you find there, I think like 95 to 98% is something that Tika can extract at least some information out of. The thing that isn't covered is typically proprietary formats for which no open source libraries exist, and those are a little bit tricky to support in an open source project. So what's kind of the solution to that is basically we have this pretty extensible plugin model, so you can write your own plugins to deal with document formats that you want to deal with. So for example, within Adobe, we have a couple of custom plugins for the formats that we're using internally. There's also a couple of other extra features. It does basic language detection, so it can know like whether this document was written in German or in French or English or so on. It isn't too great. It hasn't received that much attention, but it's there, and it's kind of there's some interest in evolving it, and some other features that are occasionally useful. And there's the website, so for more information. There's also a nice summary from Olo about what Tika is today. That looks pretty good to me. It's being actively developed. It's pretty stable and a pretty large code base already. So nowadays I feel pretty happy about the project, considering the state from where we started 5 years ago. So it's a nice thing to have. So let's get a little bit deeper what Tika actually in practice does. So we have basically a demo app that can be used to kind of play around with Tika. I'd like to show you a little bit how it works, because it's very useful for trying things out and figuring out if something doesn't work as you expect. Then just fire up this demo app and you're done. So let's take it from here. So I have a few example documents here, and I have a Tika app jar that I'm gonna run. All this stuff is also available. Let's see if it comes up. Yeah. Also available on the GitHub. So I'll show you the URL in a moment, so you can get it from there as well. And then just try this out with these same example documents that I have and the same Tika app jar. So basically this It's a very simple UI. You just drag and drop files or URLs or stuff like that on top of this window, and it'll run them through Tika and give you all the output that it gets. So, for example, here I have a PDF document that's really simple. I'll just drag it on top of the Tika window here. And then it gives me first all the metadata that's embedded in that PDF. So you see here we have stuff like who created the document, what's the title of the document, and stuff like that. Detailed metadata that you can get out of PDFs. And then you can switch to a different view of what came out of it. There's the plain text. That's just the basic text that's inside that PDF. And to show you, well, this is a very good example of the formatted text, but let's take, for example, a Word document where we have tables and headings and stuff like that. So Tika can also extract that stuff. So again, we get the metadata first. And then let's look at the formatted text. So this is a Word document with some formatting to it. There's a table. There are a couple of links and stuff like that. It isn't kind of one-to-one mapping of the formatting in the Word document. So let's see if I can open that one. So this one looks a little bit nicer. But the main thing here is that we're trying to preserve kind of a semantic level of what looks big in the document is probably a heading. Then we map that into a heading. And what is a link remains a link, so you can use that information. And what are paragraphs? They remain paragraphs in the extracted text. So you don't have to kind of reinvent structure on top of that. Also, even though you'd assume that images aren't really very useful for content extraction, Tika supports them too. And there's also actually quite a lot of metadata typically in various images. There's stuff like bit sizes, how big the image is, copyright information, and if it's kind of a professional, part of a professional like image editing workflow. And there's a whole lot of metadata that's really useful for many cases. In this case, the image doesn't contain any text, so the text content is empty. You only get the metadata. So that's a simple example. Let's switch back here. So how this Tika app works, this simple GUI tool. It's easy. Like if you're dealing with something you want to figure out what I can get from Tika, just open this up and try it out. As I said, there's a GitHub repository where I have all these example documents and the Tika app jar, so you can just fork it from there and try it out. A nice thing about the Tika app is that it also works as a command line tool, so that's already a little bit more into the area of integration with things. So you can use it to extract basically the same kinds of views that we have on the GUI, but do it on the command line and then post-process it or save it somewhere and so on. Finally, there's pretty extensive help, online help to the Tika app, so you can get more details on how it really works and what you can do with it. It's a pretty nice tool. Then kind of if that doesn't cover all your needs, there's a Java API that you can use. It's basically divided in two layers. There's kind of a simplified facade class called Tika that's basically meant for all normal use cases. If you want to just get the text out of a document, you can call parse to string and give it a file or input stream or something like that. And Tika does something that's fairly reasonable for the vast majority of use cases. So you get pretty far with the Tika facade. There's also support for type detection and metadata extraction and language detection and stuff like that. So you can do quite a lot with it. But then, like, if that isn't enough, just like with the Tika app, you can't do everything with it. So there are cases where you need to kind of reach a little bit deeper. And there's a set of interfaces in Tika that allow you to do that, and also allow you to extend Tika itself with new functionality. So you get a lot of control, a lot of flexibility, and also extra power with features that aren't exposed by these higher level things. But unfortunately, then you have to write a lot more code yourself because the programming model is a little bit more complicated than with these simple tools where you just drag and drop or write a simple command line or a one-liner like this parse to string. So you're typically dealing with dozens of lines of code when you're going to the lower levels of Tika. I'll have a few examples later on how this really works. So before we go there, let's take a look at kind of a higher level integration and how it works. Solr comes with this Solr cell contrib module called the ExtractingRequestHandler. It's basically a Solr component that allows you to upload documents to Solr index and have them automatically processed by Tika as they are being uploaded. So instead of uploading just a binary blob and then not knowing what it actually does, you kind of upload the blob, and then actually the text and metadata inside that blob are stored in the index. So you can search for it and do all sorts of good stuff with it. So here's a simple example of how you could do that. Just upload a simple document to the ExtractingRequestHandler, and then it goes there with the ID field that says document, and then the text field, the default text field containing the extracted text of that document, and the metadata fields that we saw in the Tika GUI, they end up in as fields of that document as well. So, and this is kind of this is controlled both by the arguments that you give here in the HTTP request and in the configuration that you have, and also it depends on the schema that you have for Solr. So let's go through a couple of the more common options that you can use to control this stuff. So there's a lot of parameters. You'll find all of them on the ExtractingRequestHandler wiki page. There's quite a few examples there as well, like what you can do with it and how they can be customized and so on. But here's kind of some of the more prominent ones. First, some options that kind of go directly into Tika. They're basically parameters of Tika itself that help Tika do a better job with the document. So you can pass in the name of the document. For example, if you know that this is something .pdf or something .doc or so on, then that might in some cases help Tika to automatically detect the document type, or perhaps to make a better guess of what this document really is about. Sometimes the differences between two document types are really tiny, and it's really hard to tell by just looking at the bytes whether this is this kind of document or that kind of document. A good example is, for example, source code, where looking at the actual text or the bytes of the file, yeah, okay, that looks like source code, but is it really C or is it Java? Is it Objective-C or C++? No, I can't really tell, but if I pass in the file name along with the document, then it's obvious which kind of a document this really is. So that helps in such cases. Another case where Tika basically needs a little bit of help, or quite a lot of help in this case, is if you're dealing with the document that's password protected. So that's fairly common for things like PDFs or some sorts of Office documents that are kind of limited to a certain audience. But you might still want those to be indexed, so you can pass in the information needed to process that, either as a kind of, okay, use this password for this specific document, or then you could configure that, okay, all my PDFs are going to have this password, or all the files with the code secret file project XYZ, they need to use this password. So that's the information that goes into Tika. And then kind of once content comes out of Tika, you can then control what happens to it before it gets stored in the Lucene index or the underlying Solr index. First of all, like you can decide what content actually gets stored and whether you want to kind of capture specific areas of the document to separate fields. For example, there's something that you're really interested in and want to process separately, then you can do that. First of all, there's the XPath argument that basically gives you kind of an XPath query that you can use to select just specific parts of the document. So if you aren't interested in all of it, for example, in this example, I only want to index the content of links in the document. I don't care about all the stuff that's around the links. So let's just take that. So that can be done. You can also, like, the XPath stuff basically limits the stuff that goes, like it throws away everything else. Then there's these capture arguments that basically they leave the normal extracted text as is, but they also capture specific parts of the document to separate fields. So I could use the capture to get, like, for example, all top level headings and put them into a separate field. So I could search for, like, make a search for only the outline of a document instead of searching for all the content. That might be more relevant for some cases. It's also possible to capture the attributes of elements. A common use case for that is to capture the href attributes of links in HTML and other documents. And that basically works so that, okay, you get the basic document, but then you get a separate field, for example, an A field, where all these href attributes are then stored. And then you can later on go in and say, okay, what were all the links in this document? That's a fairly useful thing to have. Also, a kind of a different way of handling that if you're dealing directly with Lucene or using Tika directly. There's a slightly more powerful way of extracting links, but it's also a way more complicated. So this covers quite a lot of use cases already. So now we have, like, things that we've captured from the document. Before we actually store them in the search index, we can still do some mappings on, like, okay, we may get a content type field, metadata field from the document, but kind of that's a little bit awkwardly named, or kind of I have a schema that actually it requires that that field to be stored as just type or format or whatever. For example, if you're using the Dublin core, then you'd be using DC format. That's actually something that Tika gives you directly. It gives both the content type and as DC format. So there's kind of a little bit of duplication there. But things like this are fairly useful. The first one here is lower names. You can use it to kind of normalize the field names so that there aren't any spaces in the metadata data names. They're all lowercase and so on. So that helps to make things easier to manage. Then if you have some fields that you don't have in your schema explicitly, like your index doesn't know what to do with them, but Tika gives you, like, this whole bunch of different kinds of metadata, and you wouldn't want to just throw them away. Okay, I don't know what they are, just leave them out. You could map them into this kind of dynamic fields, and a good way to do that is to add a special prefix to them. For example, you could add a prefix that okay, these are custom fields. I don't know yet what they are. Here, an example says, okay, these are just metadata something fields. So then you take the original name of the document and prepend metadata to it. So for example, if you have an author metadata field, it would become metadata author with this mapping. And then you could use, for example, a dynamic field configuration in your schema to figure out like, okay, I just want these ones all to be indexed and stored so I can do with them something later on when I figure out what they really mean. And then basically the most powerful mapping, you could just rename specific fields in whichever way you like. So take the original name of the field as it came out of Tika and then map it to something else. A common thing that's actually part of the default configuration is to map the content field. That's kind of a special field that comes from Tika. That's basically the extracted full text content of the document. And that gets mapped to the text field that by default in Solr is configured to be indexed in a reasonable way. But you could kind of, if you wanted to have a special schema for all your binary documents, and then the content is going to be, I'm actually going to want to store the extracted text. Then you could like use that, or kind of leave it to just content, or map it to some other name, and then have a special schema for that. So there's a whole lot of these kinds of options, and adding new ones isn't too difficult. So if something that you you'd need isn't covered yet, it is fairly straightforward to extend it. Just add it there and send a patch, and I suppose it'll get added to the code base for the next release. So that's about Solr. And then I'll look at kind of how to do stuff directly with Lucene. So then we're talking about Java code and calling Lucene stuff directly. And here we're covering also some of the internal Tika stuff in more detail. So here's some code examples. So let's start with something simple. This is the Tika facade in all of these examples still. So we're talking about fairly high level stuff still. The first thing is very simple. We just want to get text out of a document and then store it in a Lucene document as the text field. And that's all you really need. It's fairly simple, and the defaults in the Tika facade are fairly reasonable. So you don't really need much more than that. Then if you want kind of, one of the kind of reasonable things is that okay, you don't want a string that's 2 gigabytes in size because that'll crash your application. So the parse to string actually has a built-in size limit. Okay, I'm not gonna give you more than, I think the current limit is something like a few dozen kilobytes of the document. So you could get a reader instead and pass it to Lucene. Of course, Lucene has its own limit also on how many tokens to index and so on. So kind of there are two ways of limiting the amount of content that goes into the index. But basically, if you can then like get the full content of the document by using the reader. And the nice thing about this is that for document types where that is supported, we never actually read the entire document into memory, and we just parse it as we go along. And then you could get also some bits of metadata out of it, still using the Tika facade, but now we're also kind of at the limit of the stuff that the facade can do. So you can pass in this metadata object, and then Tika will fill it in with all the information that it gets from the document. And then you can just get that and add it to the document as separate fields. So here we have a simple type field that gets the content type of the document that we just parsed. So there are some things to consider. As I said, the document could be really large, and you don't want to have out-of-memory errors in your code, because then, like, when you get to an out-of-memory situation, it might be some completely different thread that fails instead of the thing that you're dealing with. So that's a little bit nasty. The good solution to that is only to deal with the first n bytes or characters, typically some kilobytes or megabytes, but not gigabytes. There's support for that. There's a class called WriteOutContentHandler that basically you give to a Tika parser, and then it kind of only accepts this many characters, and then it stops the parsing process after that. As I said, this is by default enabled in the Tika facade, so you don't really need to worry about that until you actually need more content than just the default limit. And then there are cases where a document really is badly broken, like it's malformed, and then the parser library can't deal with it. Or we have something like zip files that contain zip files that contain zip files and so on, that actually explode to terabytes or even more content. And then they could be just a couple of kilobytes to transmit. And you don't want to, especially if you're dealing with stuff that comes from the internet, you don't want your server farm to start processing terabytes of content just because someone sent you a simple attachment with a couple of kilobytes. So we have some code that kind of automatically monitors this stuff and makes sure that, okay, if for example an archive is producing way more content than the archive is than the size of the input document is, then it's most likely some problem like this, and then we terminate the processing directly. There's also a couple of more sinister parts. For example, there are documents that will crash your JVM entirely. For example, with PDFbox, we had a lot of problems because it would use the font support in the JVM or the JDK, and then it was using some native libraries that had bugs in them and still do in the latest Java versions. So if you send in a document with this specific font that's a little bit malformed, then as soon as PDFbox starts parsing it, the entire JVM will crash, which isn't very nice, especially if you have a server process that's supposed to stay online for a longer amount of time. So, and that's really hard to really detect or deal with when you're running in embedded mode, because to detect whether a document has a problem like this, you'd have to parse it, and then to parse it, you'd hit that problem. So no nice way out of it. We do have a solution though. It's already in Tika and supported. It's called forked parsing. So you can actually start new JVM processes and set up sandboxes with them, like limit the amount of memory and other resources that are available to those processes. And then we send the document to that child process or to a separate server where the process is running. And then it'll try to parse it and send back the results. And then obviously if that process fails, then we don't get anything out of that document, but at least your application that's running in the original JVM, it will be unaffected. Unfortunately, that kind of part of the code base is still a little bit tricky to set up, so you'll need to spend some effort to make it work. But we're using it in production. It's really nice when you don't have to worry about such problems. So the last thing before questions, You can also, as I mentioned, with Solr, there's a way to extract links and store links in the document for later processing. If you're writing something like a web crawler and you want, okay, I want all the links and I want to start following them, and then you want it to support also something else than just HTML, then Tika is very useful because it basically gives you links both from HTML and all sorts of other formats that support the concept of a link. As I showed earlier in the demo with the Word document, we actually get the links from there as well. So this now we go into these content handlers and how the Tika parsers work and so on. So basically we have SAX content handlers to which the parser sends events about all the content that it's extracting. And then we, for example, in this example, we use a link content handler. Basically just listens to those SAX events and then captures, okay, here's the link. I'll just capture the text of the link. I'll capture the URL. I'll process any base URLs and stuff like that you may have in place, and then keep that information around. And then I'll just throw away all other content. And you could combine that with another content handler here, the body content handler, that captures just the text that's inside the HTML body or the body of the extracted document. And the T content handler class here is combining these. So all the events that come from the parser get sent to both these things. And then at the end of the example, we basically just print out everything that we got here. And basically the link class that you see here, it gives you access to the text content of the link, the URL, and possible CSS classes and ID information and stuff like that's associated with the link. So that's about it. I think we have a couple of minutes left. So if there are any questions, I'd be happy to answer them. Okay, so the question was about document detection, and if you give like the file name and it's actually wrong, what happens? Well, Tika uses these kind of multiple levels of heuristics to detect the document type, and it will basically have kind of ranked them in a set. So you start with the ones that are more reliable. So you look at the actual byte patterns in the document, and if you find a match there, then any other hints that you have, for example, the file name, or ultimately you could provide a hint that, okay, if you don't detect anything else, then I want to say that this is of this type. For example, fall back to text plain instead of just a plain octet stream. The types or hints that are lower in the hierarchy can only specify or kind of make the earlier or the type that was detected earlier, make it more specific. So you'd go from detecting, okay, this is XML, and okay, this is actually XHTML or some other XML format. But you can't go from XML to PDF, even if you say that, okay, the name of the document is something.pdf, but if it looks like XML, then Tika will say that it's indeed XML. So the question was about detecting the language of a file by the file name. I guess you could do that. It's not supported currently by Tika. The way the language detection works, it basically works on top of the Tika parsers, so only after the things like file name information is already processed and passed in. So currently that information won't get into the language detection. But I guess if we have a good set of rules that, okay, if this looks like a Chinese name, then the likelihood that the content of the file is also Chinese is bigger. I think our time is about to end. If there are more questions, I'll be around. And we'll be happy to answer them still until at least the next next session and then later on today, of course.